Welcome to the software development cycle. Software engineering. The software engineer oversees the life cycle of software development, including initiation of the project, analysis of the specification, and design of the program, as well as implementation, testing, and maintenance of the final project. Margaret Hamilton, who you see on the right, is a computer scientist who developed the onboard flight software for the Apollo space program, and she coined the phrase software engineering. Her code prevented an abort of the moon landing. We're going to look at the different software development models, including prototype, incremental development, rapid application development, agile software development, and waterfall. We'll start with prototyping. With the prototyping software development model, an application of final system is built, tested, and reworked until it is acceptable. The complete system is then developed from the prototype. Incremental development. With this software development model, the software is designed, implemented, and tested a little bit at a time until the product is finished. The rapid application development. The user is actively involved in the evaluation of the product, and modifications are made immediately as problems are found. Radical changes in the system are likely at any moment in the process. Agile software development. The developers offer frequent releases of the software to the customer, and new requirements are generated by the users. This has a short development cycle that are common in this type of development. The waterfall model. The process of development is sequential and flows downward like a waterfall. The steps include conception, initiation, analysis, design, construction, testing, implementation, and maintenance. The waterfall model of software development came about in the 1960s in order to bring structure and efficiency into the process of creating large programs. So what's the best model? Well, it depends on the situation. It varies from problem to problem, situation to situation, and even company to company. You should review the models of software engineering as tools in the toolbox, in which the techniques that you apply depend on the project you are working on. You'll often see in software development job applications or in when they're hiring new people for jobs that they'll list a particular software development model that they're looking for experience in. Program specifications. The specifications are written descriptions of the project. Typically, the specs are based on the customer's requirements. They are delivered from the design team, not written by the programmer. Descriptions of programs should include what it will look like, how it should operate, and what it should accomplish. The first step in writing a program is to analyze the specifications. Make sure you, as the programmer, understand them and clarify with the customer or the design team anything that is unclear. Great programmers have good communication skills, so they can talk back and forth with the person who writes the specs to clarify any questions they may have. Program design. This is the detailed plan for solving problems outlined in the specifications. The program design will include objects that will be used in the solution, data structures that will implement them, and detailed lists of tasks that are to be performed by the program. A good design provides a fairly detailed overall plan at a glance without including the Java code. Program implementation. You should know that during the implementation phase, coding is the least creative stage of the life cycle. Testing and debugging. Test data is typical values in each part of a domain of the program. Types of errors or bugs include compile time error, runtime error, and intent or logic error. A compile time error is the compiler is unable to translate the code into bytecode and prints an appropriate error message. A syntax error is a compile time error caused by violating the rules of the programming language. Runtime errors occur during execution of the program. The Java runtime environment throws an exception, which means that it stops execution and prints an error message. Typical causes of runtime errors include attempting to divide an integer by a zero. Intent or logic errors is one that fails to carry out the specifications of a program. For example, a logic error might be that you created an expression where you wanted to multiply 3 times 3. But while you were coding it, instead of putting a multiplication operator, you put an addition operator. The program is still going to work, but it doesn't give you the output that you expected because of that logic error. And then robustness doesn't give inaccurate answers to some input data. It doesn't crash if the input data are invalid. For example, if you are asking the user to put in an integer and instead they type a word. For example, if you ask them to put in a 2 and you're expecting a numerical 2 and they type TWO, you don't want the program to crash. Instead, you want to give them an appropriate error message that says they need to enter a number or an integer. And it doesn't allow execution to proceed if invalid data are entered. And program maintenance is going to include things like upgrading the code as circumstances change and adding new features. Because new people will be added to projects, original programs must have clear and precise documentation. And this concludes the software lifecycle presentation.